Look up at the night sky. Imagine the vastness above, stretching farther than our eyes can see, filled with countless points of light. Each star is a distant sun, and for most of human history we could only wonder what secrets they held. For centuries we saw only stars, beautiful, mysterious, and seemingly unreachable. Ancient astronomers mapped the heavens, dreaming of what might lie beyond, but the universe kept its distance, its mysteries locked away. But now, we know our solar system isn't unique. There are other solar systems, other planets circling other stars. The question, are we alone, is no longer just a dream or a fantasy, it's a real scientific quest, one that drives us to look deeper. The James Webb Space Telescope, or JWST, is our golden eye in space, peering deeper than ever before. It's the most powerful space telescope ever built, designed to unlock the secrets of the cosmos. Its giant gold-coated mirror captures ancient light, revealing secrets from the dawn of time and from our cosmic neighbors. With every observation, JWST brings us closer to understanding our place in the universe. JWST sees in infrared, letting us peer through cosmic dust and uncover hidden worlds. It can reveal planets and stars that were once invisible, hidden behind veils of interstellar clouds. The search for life beyond Earth is now real science, and JWST is leading the way. Scientists around the world are using its data to hunt for signs of habitability and even life itself. Every image, every data point could rewrite what we know about the universe. Each discovery is a new chapter in the story of our cosmic neighborhood. We're not just stargazers, we're explorers, charting new territories with a telescope sailing through the void. Our journey is just beginning and the possibilities are endless. Our quest, to find other planets, other Earths, and maybe, just maybe, signs of life. We're searching for places where life could exist, or perhaps already does. The universe is waiting to tell us its stories. Each discovery is a clue, a piece of a puzzle that stretches across billions of years and trillions of miles. What are we looking for? Worlds orbiting other stars, exoplanets. Some may be rocky, some gaseous, some with atmospheres and some with oceans. Before the 1990s we had no proof they existed, now we know of thousands. The discovery of exoplanets has transformed our understanding of the cosmos. The Milky Way could be teeming with trillions of worlds. Each one is a potential new home, a new story, a new mystery waiting to be solved. JWST is our guide, helping us not just count these planets but understand them. Is it rocky? Is it covered in clouds or oceans? What secrets does it hold? Does it have an atmosphere? Could it support life? Could there be water or even living creatures waiting to be discovered? These are the questions that drive us. With every new world we find, we take another step toward answering the greatest mystery of all. Are we alone in the universe? An exoplanet is simply a planet orbiting a star outside our solar system. These distant worlds are scattered across the galaxy, each one circling its own sun, far beyond the reach of our own familiar planets. For centuries, these worlds were just speculation. People wondered if other planets like Earth existed, but we had no proof. Finding them is like spotting a firefly next to a searchlight, nearly impossible, but modern astronomy has made it reality. With new technology and clever techniques, astronomers have finally been able to detect these faint, distant planets. Why do we care? Each exoplanet is a new clue to how planets form and evolve. We've found hot Jupiters, super-Earths, and even planets orbiting two stars. Some are scorched by their suns, while others are frozen in darkness. The diversity is staggering, challenging our ideas of how solar systems work. There are planets with rings, planets with clouds of gas, and planets that defy our expectations. Telescopes like Kepler and TESS found thousands of exoplanets, showing us that planets are everywhere. Almost every star you see in the night sky could have its own family of planets. But knowing a planet exists is just the first step. It's a bit like finding a single shell on a vast beach. You know it's there, but you don't know its story. It's like knowing a book exists without reading it. The real adventure is opening that book and discovering what's inside. What are these worlds made of? What's their weather like? Are their skies blue or red? Do storms rage across their surfaces? Do they have oceans or continents? Could there be alien landscapes or even the right conditions for life? This is where JWST comes in. The James Webb Space Telescope is our most powerful tool yet for exploring these distant worlds. It's not just about finding more planets, it's about understanding them. JWST lets us peer into their atmospheres and search for signs of water, clouds, or even the building blocks of life. JWST can analyze the light from these worlds in detail, giving us our first real glimpse into their nature. We can start to answer questions that were once pure science fiction. It's the difference between seeing a dot and seeing a world. Suddenly, these distant planets become places, not just points of light. We're moving from detection to description. We're beginning to tell the stories of these far-off worlds. The universe is full of stories and JWST is helping us read them, one exoplanet at a time. How does JWST find exoplanets? The James Webb Space Telescope is one of humanity's most powerful tools for uncovering planets beyond our solar system, worlds that are hidden in the vastness of space, orbiting distant stars. One key method is the transit method, a clever technique that lets us spot planets by watching for tiny changes in a star's brightness. When a planet passes in front of its star, it blocks a tiny bit of light. JWST can detect this faint dip, even when it's just a fraction of a percent. By measuring the dimming, we learn the planet's size and orbit. The timing and depth of the dip reveal how big the planet is and how far it travels from its star. This method has revealed thousands of worlds, showing just how common planets are. It's helped us realize that planets come in all shapes and sizes, from rocky Earth-like worlds to giant gas planets. JWST's infrared vision is perfect for spotting planets around cool, dim stars called red dwarfs. These stars are the most common in our galaxy, and many have planets in their habitable zones. Another method is direct imaging, actually seeing the planet itself, instead of just its effect on starlight. JWST uses coronagraphs to block the star's glare, revealing faint planets nearby. This technology acts like a shield, letting us glimpse planets that would otherwise be lost in the star's brightness. Direct imaging works best for large, young planets far from their stars, where the planet's own glow can be seen more easily against the darkness of space. Each method gives us different clues. Transits tell us about numbers and sizes, while imaging provides direct views and even lets us study atmospheres. By combining these tools, astronomers build a fuller picture of distant worlds, piecing together their mysteries bit by bit. JWST is a master of both, revealing the hidden gems of our galaxy and opening new windows into the unknown. The hunt for exoplanets is more precise and exciting than ever, with each discovery sparking new questions and possibilities. Every discovery brings us closer to understanding our place in the cosmos and reminds us that the universe is full of worlds waiting to be found. Finding a planet is thrilling, but the real magic is studying its atmosphere. JWST uses transmission spectroscopy. When a planet transits, some starlight passes through its atmosphere. Molecules like water or methane absorb specific colors, leaving a chemical fingerprint. JWST spectrographs spread the light into a rainbow, revealing which molecules are present. For the first time, we can do chemistry on worlds we'll never visit. Does the planet have water vapor, methane, carbon dioxide, clouds? We're moving from knowing a planet's size to understanding its composition and climate. JWST can detect even trace gases, offering clues about habitability. The presence of both oxygen and methane could be a powerful sign of life. It's a long shot, but JWST finally gives us the chance to look. We're reading the barcodes of alien worlds, searching for signs of life. In just a few years, JWST has delivered spectacular results. It studied WASP-39b, a hot Saturn, and made the first clear detection of carbon dioxide in an exoplanet's atmosphere. JWST also found water, sulfur dioxide, and evidence of photochemistry, complex processes at work. It's like getting a weather report from a planet 700 light-years away. The TRAPPIST-1 system, just 40 light-years from us, has 7 rocky Earth-sized planets. 3 are in the habitable zone, making them prime targets for the search for life. JWST has begun studying these worlds, searching for atmospheres and signs of habitability. Early results show some planets may lack atmospheres, but the search continues. Each new observation is a piece of the puzzle. JWST is revealing chemistry both familiar and alien, building a library of alien atmospheres. We're in a golden age of exploration. The most exciting discoveries are still ahead. Astronomers search for planets in the habitable zone, the Goldilocks zone, where it's not too hot, not too cold, but just right for liquid water. Liquid water is essential for life as we know it, but being in the zone doesn't guarantee habitability. Venus and Mars are in our sun's zone, but neither is Earth-like. A planet's size, composition, and especially its atmosphere matter. JWST can check if a planet's conditions are truly just right. It can detect water vapor and other gases, revealing if a planet has a protective atmosphere. The goal: find an Earth-like planet orbiting a sun-like star. But life might exist in unexpected places, icy moons or planets around red dwarfs. JWST is expanding our definition of habitable. It's giving us real data on a wide variety of worlds. The universe may be more welcoming to life than we ever imagined. We're pushing the boundaries of what's possible. The search for a second Earth is just beginning. For millennia, "Are we alone?" was just a dream. Now it's a scientific quest. With JWST, we're finally able to search for life with real evidence. Every spectrum of an exoplanet's atmosphere is a step toward an answer. We may not find life tomorrow, but the search has truly begun. The possibility of finding even simple life would change everything. It would show that life is not a fluke, but a cosmic phenomenon. Even if we don't find life, the search teaches us about our own planet. Studying other worlds helps us understand and protect Earth. The journey is as important as the destination. Next time you look at the night sky, see not just stars but suns with their own families of worlds. Wonder what's out there, oceans, skies, maybe life? Keep asking big questions. The universe is vast and the quest continues.